And welcome everybody to the Daily Space Weather. I'm your host Dan, aka smAsho. We see a coronal hole wind stream just arriving, the sun briefly returning to quiescence, the 12 days of censorship, Comet Erasmus, and more. So join me when we look at all the data relevant to what's going on in terms of the weather in space. First, the sun in three different wavelengths, 335, 193, and 94 angstroms. We're back to zero sunspots, but there are active regions rising. You can see that bright area in the southeast. And for you new viewers, this is the east side of the sun. And that active area is right there. Whether it's a sunspot or not, you'll have to remain in suspense about the 10.7 centimeter radio flux. The radio output of the outer corona is at 82. So there's the 1 year chart of the radio flux, and the radio flux is a proxy for sunspot number. Not really a proxy, it's just directly proportional to sunspot number. And there you can see how similar those graphs are, the upper one being sunspot number progression, and the lower one being the 10.7 centimeter radio flux. Next, looking at the intensity gram to see sunspot 2793 evaporate. And you can barely even see it. It's right here. It was right there. But now it's gone. So there you can see that little sunspot now gone. No sunspots. Now, we're going to show you a video of this a little later on our HelioViewer movies section, which we've saved for the end today. Right there you can see Comet Erasmus on the LASCO C3. Let's take a look at the sun from the viewpoint of stereo A, located at Lagrange point 5. First, let me check the life of the stream, and we are looking just fine. We are streaming live to twitch.tv. So here's the view from Lagrange point 5. We're going to look at the stereo A 195 angstroms view. And this is the active region we see moving into the Earth-facing zone. Not sure if that's a sunspot or not. We'll have to remain vigilant watching that. Next, I'd like to thank our patrons, the true source of funding for the content. Patreon.com/smAsho. If you'd like to support the channel, please do. We encourage you to. Thanks, patrons. Again, it's patreon.com/smAsho. Help increase the probability that these videos will remain free and publicly visible. Today's Smash Lights segment will be relegated to a different video. So I would invite everybody to press like and subscribe if you're viewing on YouTube. Share on your social media. We will be streaming live exclusively to YouTube for the moment of the solstice, which happens at December 21st. Monday, December 21st at 5:02 and 20 seconds. We'd like to be the first channel to wish you a happy solstice. So join us for that at that time. Less than 2 days of either autumn or spring remaining, depending on what side of the planet you're on. Thanks to all of our new viewers at YouTube. Again, please press like and subscribe over there and share the content on your social media. Tell your friends, your foes, your science noobs, and your science pros about the channel. And we're also on BitChute, thanks to our new subscribers over there, which brings me to the 12 days of censorship. Now, let's switch it. I'm going to switch it up here. If you don't follow me on Instagram, you may not have seen this post. On the 12th day of censorship, social media gave to me 12 wasted hours, 11 abused powers, 10 asinine admins, 9 shadow bans, 8 posts not seen, 7 pointless patches, 6 software crashes, 5 memes of Mark, 4 failed posts, 3 posts purged, 2 outright bans, and 1 account unable to post. We'll talk about that at a later time in our live stream, which we'll do later today. Also, don't forget to visit our own websites, smAshomash.com. You can find our social media links there, as well as links to the forum and the 2 stores. Don't forget to enter the promo code SMASHO on all orders at the stores to save 10% at checkout through Christmas. So do yourself a Christmas favor. Maybe pick up a mask that says, "Are you safe yet?" Or perhaps our first piece of merch that we've ever made. Thanks to everybody who's picked up some. Smasher price, my first pandemic t-shirt. Yeah. And again, we are streaming live to Twitch thanks to our new follower over there, twitch.tv/smAshomash. A great live streaming platform. And we're going to talk cosmology for a brief moment, as we regularly do in the Daily Space Weather video, because the space weather is part of cosmology. So let's get a random number here using my quantum dice. My quantum die has rolled a number of 844. And let's see what the object is at 844 at the Neil Gorell's Swift X-ray Observatory. It's a, I don't know what a CV/DQ her is. I thought it was going to be a quasar. It looks like it's a galaxy, though. 4U1849-31. So there are the X-ray emissions from it. It did have an interesting moment here around 2011. And I have reasons for looking at all these objects, folks. I'm including you, the viewer, in my analysis of what's going on with all kinds of deep space objects. And you can see it's actually gone to a state of quiescence here, as well as the sun here in the past few days. There are the past 2 weeks, barely any X-ray emissions, although it is historically a consistent X-ray source. Let's see if we can see it on Simbad and on Aladdin Light. So there it is on Simbad. Certainly looks like a bright galaxy, showing a blue color spectrum. And we'll look at it in Aladdin as well here. Alternate name is V star V1223 Sagittarius. So it must be in the Sagittarius constellation. And again, a radio galaxy. Here it is on Chandra. Not showing up on Chandra. How about on the 2MASS, the infrared spectrum? And there it is on the 2MASS. And that's today's cosmology segment. A small analysis of the X-ray output and visual status of 4U1849-31, a catchy name. Let's get back to data. We see a coronal hole wind stream arriving, and it's quite dense. So don't be surprised to see possibly even geomagnetic unrest kick up today, as the coronal hole that has sent that stream is quite significant. We'll show you toward the end of the video. Solar wind density all the way up to 20 protons per cubic centimeter. And solar wind speed having just ramped up a little bit to 336 kilometers per second. What we're going to look for here is for that solar wind density to drop and the solar wind speed to rise. When that happens, possibly see the KP index move up a little bit. It's currently at 2. Don't be surprised to see that at 4. Again, that is a significant coronal hole. And here's what's going on in the magnetohydrodynamic pressure. We're looking at me vanishing, and there you can see that uptick happening in the past couple of hours of the solar wind density. Again, watch for the density to drop and the speed to go up as the coronal hole wind stream hits in full force. And that's 4 hours of data, if you were wondering. Here's 4 more hours of data based on the same space weather modeling framework, but looking a little bit closer to home. This is induced magnetism on the surface of the planet, and you can see magnetic perturbations, changes in the Earth's B field there over both the Canadian and Siberian North Poles. Yes, there are 2, as well as in the southern hemisphere, and they're pretty spread out over Antarctica. Let's look at the polar view as well. I'll let this play through a second time here as the polar view loads. In any case, welcome to the Neo-Renaissance. Welcome to the magnetic excursion. Has your brain been completely shattered by cosmic rays? Have you been leaving ridiculous comments on our social media? Well, congratulations. You've been cosmic ray fluxed. Have you done something dumb like move to a massive cosmic ray flux center? And let's bring that back and look at 4 hours of magnetic perturbations at the poles. And you'll see a characteristic S shape most likely kick up over the north. Again, there's a North Pole over the northern Canada area as well as Siberia, which places the net North Pole someplace between Greenland and Svalbard. And the South Pole has moved toward Australia, well off of the Antarctic continent, as you can see there. We don't see any significant proton events happening in the past 3 days, or indeed the past week. There's the 1-year chart of the proton flux. And it's a pretty important variable. And we've only seen one small solar flare there of the B class, which happened around 1720 yesterday. Nothing to write home about, but we did see an increase in the output of the X-ray flux here overall, and that's most assuredly that rising region in the southeast. If you're up before dawn, you may see the moon. You may see, what am I saying? You may see Venus, rather, rising before the sun at a magnitude -3.9, the third brightest object in the sky. Here's what's going on in the solar system, and you can see this Jupiter-Saturn alignment coming up on the same day as the solstice, by the way. First time that's happened in about 800 years. There's where things will be in a week. And there's where the alignment happens from the perspective of the Earth. It'll look like one single very bright object. We see some pretty steep curves here in the GOES magnetometer. Now that we're moving on to the magnetic section, I'll reappear. So there's a 3-day chart of the GOES magnetometer, which measures the magnetic field at the F ionosphere layer. And you can see these spiky sawtooth patterns happening. Keep in mind the plasma that is on the way from the sun to the Earth right now as a result of that coronal hole wind stream does affect the magnetometer. So here's the ecliptic plane field plot. And what this is showing you, if you're a new viewer out there, this is showing you the polarity of the current sheet. So that area there I drew in, that's North Pole shown in green. Here's South Pole shown in red. And those protons coming out of the sun, they get aligned as per one of the solar polar fields. The North Polar field, again, shown in green. South Polar field shown in red. And the Earth remains in the North Pole current sheet. I would not expect to move into the South Pole current sheet anytime soon. There's the latest image right in the middle of that. And we're going to actually see some weak GOES magnetometer readings as a result of the way that looks. Here's a line of sight coronal hole plot, and you can see that large North Pole oriented coronal hole up here. That's where the protons are coming from. And they actually showed up a bit early. That is a wide gaping coronal hole. So here's one that also shows you the magnetogram, the line of sight field plot, and it's showing you the sun's B field there in blue. And last but not least, we'll look at the sun's atmosphere, the magnetic field plot of the solar corona. And before we move on, let's make sure that we are good to go here. Thanks for tuning in. Precious Slights and JapDX. Thanks for leaving comments. Protons are high because there is a coronal hole wind stream. Yes, yes. Now let's get back to some more data here. Now we're going to talk electrons. We don't see significant charging hazards, but a little bit over the central Pacific there, surprisingly, even though the electron flux is low, and we're expecting it to remain low and indeed get even lower throughout the duration of this coronal hole wind stream. There's a 1-year chart of the electron flux, and you can see the forecast agrees with me here. NOAA forecasting a downtick in the electron flux. There's the 3-day chart of it, and expect to see this cratered. Here's a visualization of the total electron content forecast, which shows you data all the way up to the thermosphere where a GPS satellite will be located. Some surprisingly dense regions there, and we see more anomalies at a low level of electron flux than a high level of electron flux. And you can see some anomalies there over North America, perhaps causing some unexpected GPS errors. Turn on your Wi-Fi sensitivity, as you can increase the accuracy of your GPS that way, using the IP addresses of local internet connections. Here's a diagram, and we just like to show this to give people a good idea of where stuff is located. You can see the inner Van Allen belt there, as well as the outer Van Allen belt, and the altitude of GPS satellites, the SDO, and the International Space Station. Here's a diagram of just the atmosphere, all the way from the troposphere where all your weather occurs. And it also shows you things like penetration of electromagnetic radiation, UV down to visible and infrared light. And if you look at that red F over on the right, that's where the GOES 16 is making its measurements. Here's a visualization of the ionosphere. And this one's courtesy Government of Australia Bureau of Meteorology. And we see a bit of anomalous charge ups there in the southern hemisphere once again. And this won't go super crazy, folks, as a result of that coronal hole wind stream. You can watch it throughout the day if you like. And we'll bring up the latest image here, coming at you pretty late today at 12:30 Universal Time. And you can see how charged up this is even at nighttime in the southern hemisphere. That was 24 hours of the ionosphere. Next, we'll look at volcanoes, and we see a slight uptick here. Klyuchevskoye erupting, 23,000-foot ash plume above that caldera on the Kamchatka Peninsula. Abiko, an uptick there, 17,000-foot ash plume. 6,000-foot ash plume at Mount Ibu. Popocatépetl, mild explosive activity is an indication you probably shouldn't build a campsite on the lower slopes of Popocatépetl. Fuego's exploding, flight level 140. It's a 14,000-foot ash plume. Sangay exploding, 20,000-foot ash plume there. Revenador exploding, 14,000-foot ash plume, and continuous emissions of gases and volcanic ashes coming out of Sabancaya down in Peru. Please don't pole vault the caldera. We need the views. Next, looking at earthquakes of the past 24, we see some deep quakes here. A little bit of a earthquake swarm here north of New Zealand, starting with this 4.5 at extreme depth, 517 kilometers near Fiji. And let's scroll up the list here as the 7, 8, and 9 magnitude earthquake drought continues. If you're in an earthquake-prone zone, please be prepared to be an asset, not a liability, when the buildings start to crumble. If you're wondering who the cavalry is, it's probably because you're the cavalry. Next one we'll report on is this 4.6 at Fiji at over 500 kilometers depth. Here's a deep quake under Argentina. It's only a 4.2 magnitude, but it's at 227 kilometers depth. So a couple of 5s kicking off here as this, really it's a 6, 7, 8, and 9 magnitude earthquake drought. Extreme deep quake here at Japan, struck yesterday at 2105. It's a 4.4 magnitude at over 420 kilometers depth. There's one in the Caribbean. It's only a 3.7 magnitude, but over 140 kilometers depth. Another deep quake strikes the Fiji region, a 4.6 magnitude at 490.1 kilometers. And let's move on to look at the jet streams. There's the jet stream situation of the Western world. Can I blow it up? There we go. Now it's bigger. Everything in Texas and Germany is bigger. Were you aware that everything in Germany is bigger? Die Zugspitze ist groß. Groß. That means large. Anyway, check out the extreme bends. We have a doubled up jet stream there over the US, as well as some major kinks in the southern hemisphere there over the southern Pacific Ocean. Check out this weird rift right here. You got a split happening. Let's look at the higher altitude winds for once. The 10 hectopascal. And wow, we got a really majorly shifted 10 hectopascal winds there. Check it out. Here's a rotation in the southern hemisphere. Looking a little more normal down there. The northern hemisphere, pretty jacked up when it comes to the 10 hectopascal winds. Here are the jet streams of the geographic North Pole. And let's go to the eastern world here. We don't want the video to be too long. There's the jet stream situation of the eastern world. We have doubled up jet streams in both the northern and southern hemisphere, as well as the jet stream blowing backwards over the southwestern Pacific and the Indian Ocean. When the jet stream's blowing east to west, that's not normal. Let's check out lightning. And according to lightningmaps.org, that's what's currently going on. We do see some terrestrial lightning here over Texas. Pretty minor though. Here's a GOES lightning mapper, and you'll see a little flash there over southern Texas. Nothing to write home about. Next we'll look at pressure cells on windy.com. Here's where they are now. We're going to advance it into the GFS forecast. Here's where we're expecting them to be at 12 noon tomorrow Eastern Standard Time. So doing a little meteorology here. Leave us a comment if there's some meteorological forecast you'd like. Perhaps we'll consider doing it. We are planning a live stream, another YouTube live stream exclusive after this video airs. We'll premiere this video on YouTube and then make another video, a weekend live stream, where we talk about whatever we want. It'll be a Smash Lights / the Smash News Network. And let me just check the life of the stream once again here. Again, we are streaming live when we've made this. Snow in Hawaii, yowzers. And thanks for leaving us comments once again, JapDX and Precious Lights. JapDX reporting that it is snowing in Hawaii. Would that be on top of one of the mountains? Somehow I suspect it would be. And let's get back to some more value-added services here. It's a U.S. Doppler radar map. And we see some snow showers happening there around the Great Lakes, especially surrounding Lake Michigan. And a band of rain there over Arkansas and Texas. And some snow in the northern Rockies as well. Here's what's going on in the cloud layer. We use the shortwave radiation map when it's too dark to see the clouds, and check out all the low clouds over both the Gulf and the Atlantic Ocean. Once again, low clouds there make for warmer nights and colder days as they increase the Earth's albedo effect, and they reflect sunlight back into space and also cause the greenhouse effect at night, so you get warmer nights and you get colder days. Here's the water vapor map. And low clouds are able to make the Earth cold over an extended period of time. Water vapor, cloud layer. And we'll actually zoom in here on the southern tip of Lake Michigan to give all you Great Lakes region folks some idea of what's going to go on with those snow showers. They're looking pretty unorganized. So there's the cloud layer. Here's water vapor of the Great Lakes region. And that should give you some idea if you're not aware of what's going on the Doppler. And I won't go too in-depth into this. It's nothing too extreme. Looks like it's going to take its time for the most part, as you've got this northeasterly flow happening. And we've got value-added services, so don't go anywhere. We're going to show you the solar intensity gram, the rest of our helioviewer movies, which are epic today, and the colorized magnetogram. So first of all, and thanks again, Twitch viewers, for leaving comments. We greatly appreciate that. There is the solar intensity gram to show you 0 sunspots. It is a blank solar disk. In this active region, no umbrae to be seen there. Here's the colorized magnetogram. Sort of 3 active regions there in the south. There's a close-up of the rising active region, which does not yet look like a sunspot in terms of magnetogram. And this is where sunspot 2793 evaporated. And here are our helioviewer movies. First 193 angstroms. And the wind stream that we're seeing right now is from this coronal hole, which is quite large, quite North Pole oriented, and arriving earlier than expected. And wait till you see the other views we've got today. We've got some great ones. Allow me to vanish. Here's 304 angstroms. We see some filaments out there on the west, as well as associated with that active rising region in the southeast. And here you can see Mercury swinging around toward the back of the coronagraph disk there. That's Mercury at the bottom. And in the upper right, we've got something very interesting to show you. It's Comet Erasmus. So there's a fantastic view of Comet Erasmus. And again, that's in the upper right. You can kind of see where it is based on this corner here. Right on the upper right of the LASCO C3 coronagraph. And here's the southern hemisphere of the local yellow dwarf in 171 angstroms, my favorite wavelength. Leave us a comment. Let us know what your favorite wavelength is. We're also going to show you 131, which, by the way, like 94 angstroms, takes 10 images per minute instead of only 2. And this wavelength is specifically like 94 angstroms to study things like solar flares. So there's that view of the southern hemisphere. And here's an extreme close-up of the active rising region there. So far, not a sunspot. And by the way, we only name sunspots when they are in view of the Earth, which is why we call them, quote, Earth-facing, end quote. If you can see the dark umbra, you're seeing a very flat section of the photosphere. I won't get into why the umbrae are dark. We'll save that for a later video, perhaps a cosmology segment. Anyway, it's about that time. Thanks for tuning in, folks. Remember, stare at the sun, don't drink it. If you do, don't drive. Seriously, don't drive. And since it'll never be now again, may that solar wind be at your back and that covidiously absent from your location.